Hi everyone, this is Adam again, and today I'm going to go over geometry 2. So certain things like similar triangles. So before we looked at congruent, now we're going to look at similar triangles and other sort of theorems like this. Okay, so first of all, congruent triangles are when the triangles are the exact same. So all the sides are the same length, all the angles are the same. So basically they're just the same triangle, just they could be moved around a bit, rotated maybe. That's it. Okay, so that's a congruent triangle. So we did that in geometry 1, I think. Similar triangles are probably in the name. They're similar, they're not the same. So basically it's where all the angles are the same, but they could be different sizes. Okay, so similar triangles would be something that look like this. Okay. So these two would be similar triangles. So hopefully it makes sense what I mean, that this angle is the same as this angle is the same as this angle, and this angle is the same as this angle. So it's basically just like that the one on the right is just smaller. That's basically all it is. Okay, so what you can do is, with this, is basically, if you divide the length of this side by the length of this side, that's the same thing as dividing the length by this side and this side. Okay, so it's basically, it's the same thing in geometry 1 that we were doing when we were saying, okay, the big side divided by the small side on the left is the same thing as the big side divided by the small side on the right. The same thing. So the ratios in the triangles should be the same. So if you do that, the longest side divided by the second longest, that should be equal to the longest side divided by the second longest, and so on and so on. Okay, so I'll do a couple of examples, that'll hopefully make sense. Okay, so one of the examples is this. You have this, and this. You're told that this is angle O, this is also angle O, so those two angles are the same. You're told this angle is the same as this angle, and obviously that means that this angle has to be the same as this angle. So, first of all, let's look at the sides that are kind of corresponding to each other. So this side corresponds to this side in the big triangle. Okay? Actually, sorry, let me just redraw it all together. It's probably easier if I redraw it. So if I redraw it like this, I have this is O, this is the dash, this is this one, and then the bigger one will be like this, where it's O, dash, and dot. Okay? So clearly, this side corresponds to this side, this side corresponds to this side, and then the white side corresponds to the white side. Now the next thing for me to do is just to plug in the numbers. It's 4, 5, 7, x, and y. So we have that it's 4, 5, 7, it's 7, x, and y. So just from the diagram, this side in the big one is 7. So between the angle O and the angle dash, that's the angle dash, that's the angle O, and therefore that's how I knew that that was 7. Okay? So now, what I mean by the ratios stay the same, I mean that if I do the pink side divided by the white side, that has to be the pink side divided by the white side in both triangles. So 7 divided by 4 has to be equal to x divided by 7. So x is going to be 7 by 7, that's 49, divided by 4. So x is going to be 12.25. Okay? I can do the same thing. If I do the white side divided by the blue side, that's 4 divided by 5 is equal to the white side. In the big triangle is 7, the blue side is y. So I get 4y is going to be 35. So y is going to be 36 would be 9, so it's 8.75. Okay? So that's how you deal with the triangles. Okay. I'll do another one. And so here it says you have this. And this is a right angle, and that's a right angle. This is, say, angle X. This is angle alpha. This is also 90. This one also has to be alpha. Now, think about it. Why are these two angles the same? Because if I look at the big triangle first, what do I have? I have X, I have a right angle, I have an alpha. If I look at the small triangle, what do I have? I have an X in the corner and a right angle. So if this one, if alpha plus X plus 90 is 180, and here I have X and 90, then the only other angle that can be left is alpha. Okay? So now, what you're told is you're told that this length here is 6, this length here is 12, and this length here is 10. So specifically from here to here. So now I'm going to write those in. So in the small triangle, we have that this is 10, this is 6. I don't know how long the side from the right angle to the X is. So I don't know how long that is. And I know that this here is just 12. Okay? So now, we can notice, so before it wasn't a nice number. Now we have a nice number. So this is just another thing to look at. So we're going to do enlargements in the next chapter. And then, so in the next video, I'll cover enlargements. But you can just think, these are similar triangles, which means they only differ by a factor. So basically one's just smaller than the other. What's that factor in this case? 2. The factor is 2. Why is it 2? Because this is 6, this is 12, 6 times 2 is 12. And therefore, if I asked you what's the hypotenuse on the bigger side, given that the hypotenuse in the small one is 10, the answer is 20. It's just double it, okay? So now, the next thing I want to know is, I want to know what is this length here. So this length, I'm going to use Pythagoras. So it's 10 squared is going to be 6 squared plus y squared. Do a bit of solving, you get y equals 8. So that's just a 3, 4, 5 triangle, okay? Multiplied by 2. And then this is then has to be 16, okay? So that's it. All right, so you've figured out all the lengths of all the sides. So hopefully that's all okay. Oh, that's quite interesting actually. Sorry, you could have figured out this was 16 straight away. Because this is 6. Now, does anyone know why that makes sense? Because here, you have 90 and 90. And therefore, this is just going to be an isosceles triangle. And therefore, if that's 6, this also has to be 6. And then 6 plus 10 is 16. So that's actually quite interesting. So you could have done that way too. I didn't see that. But, you know, just to let you know that that could be a thing. I'm going to skip over the next little bit because it's just telling you about Pythagoras' theorem. The next is just the area of a triangle. Fairly obvious. The area of a parallelogram, we've already done that, so that's all fine. Yeah, I might just do 1 or 2 questions just to jog. I might just do the parallelogram one because it's kind of obvious with the triangle as to what you're supposed to do. But let's say we have a parallelogram like this. And I ask you to find the area. So here you're told that this is 18. Sorry, it's 24. Down here is 18. Down here is 28. And that's to find the area. So the area of a parallelogram is just the base times the perpendicular height. So in this case, so the perpendicular height is obviously 24. Grand. But which is the base? Is it 28 or is it 4 or is it 18? The answer is 18. The base is always the perpendicular height multiplied by basically the surface that it's perpendicular to. Okay, so that's why it's 18 in this case. So just be careful not to multiply by 28. It's the base is always the one that you're looking at right angles. If they told you, sorry, I can't do that in my head, I don't know. But let's say they told you this length here was equal to 10. Then you'd say it's 10 multiplied by 28. Okay? That's all. All right, so it's always, the height is always compared to what base. Okay? That's kind of it. So I'll do one more. Yeah, this one's actually kind of hard. So you have this, you have these two lines, you have these two lines. They're parallel. So you have two parallelograms. You have this as 1.5 from there to there. You have this as 7 and you have this as 3. And they want you to find the area of the shaded region in here. Okay. Also, sorry, and this is 3 here as well. Okay. So what you can do is you can basically just say, well, the shaded region is just two parallelograms. The perpendicular height is 7 for both of them. So for the first one, the area is just going to be the base, which is 3, times the perpendicular height, which is 7. The area of the second one is simply the perpendicular height, which is 7, times 1.5. And then you just add these together. Okay? So unit squared, again, because it's areas, just be careful with that. And that's it. Okay? No more working is needed. Okay. Yeah, now there's a little bit on circles here. So basically, what we have is, this is a theorem, okay? And this is one of your theorems that you can be asked to prove, okay? So that should be in the back of your book. I'm not going to do it, but your teacher should give you these, okay? So basically, if you have 2 points like this is the center of the circle O. This angle here is always going to be 2 times the angle here. So it's always double, okay? That's all you need to know, all right? And that's the same, as long as B and C stayed the same, it doesn't matter if it's here, this will also be alpha, okay? So as long as B and C stay in the same position, A can be moved around. As long as these 2 lines contain the center. So you can't have A here, just for clarity, because this wouldn't contain the center. Okay, so as long as your kind of triangle sort of a thing would contain the center, you're perfectly fine. Okay? All right. So one of the questions here, they give you circle, this is the center, O, you have a thing down here, another thing up here, here, you've here, and here. And you're told this is 44. And you're asked, what is this angle? The answer is also 44. Because again, all you're doing is just bringing this down to here. Okay? It goes through also still 44. The second it goes under, you're not guaranteed that. Okay? But as long as you're over it, you're fine. So we have this. So that's 44. And then they ask, what is this angle in here? Obviously, it's going to be double 44, so it's going to be 88. Okay? And then finally, they ask, what is this angle here? You would say, well, this is an isosceles triangle. That's another thing that's very important to remember. All of these are just radii. Okay? And so basically, these two angles are the same. And so let's say the angle's alpha. That means alpha plus alpha, so 2 alpha, plus 88 has to be 180. So 2 alpha has to be equal to 96. So alpha has to be 46 degrees. This is very important when you're looking at circles. Remember radius, because they love to put it on. They love to put a circle there, and then you'll have to remember, oh, those are both radii. They're both radii, and then that means it's isosceles. Okay, that's the thing they love to ask. Okay. The next thing to look at is if we have a circle and we have a quadrilateral in this circle, and it contains a center point O, then this angle and the third angle, so the opposite angles will add up to 180. Okay? So angle 1 plus angle 2 is 180. And angle 2, sorry, I meant 3. So opposite angles. So just for clarity, this one and this one. This one and this one. Angle 2 plus angle 4. Like that. Another thing that they love to do is you have a circle, you have the diameter here, and it goes like this. What angle is up here? It's a right angle. Because remember, this is just this sort of diagram where this angle here is 180. So half of 180 is 90, and therefore this is 90 degrees. Okay? So just so we're all on the same page with that. All right. Okay. So let's do a couple examples now. Sorry, I'm just looking for ones that I think are quite difficult. Yeah. Okay. So this one, I'll be honest, looks awful. So here we have a diameter. We have one triangle coming down here. And first of all, this is 90. So we're not told that in the question, but I know that, okay? We're told this is 40. We have one triangle here, which comes down here. And we have another triangle here, which goes there. So again, these are all 90s. So the very first thing, they're all 90s. Won't even think anymore. You're told this is 40. And you're told this is angle A. This is angle B. And this is angle 25. Okay? So basically, figure out what A and B are. So now, there's an awful lot going on in this diagram. First things first. What angle is this down here? Does anybody know? 50. Because if we look at the bottom triangle, this is 40, this is 90. So 180 minus 90 is 90. 90 minus 40 is 50. So we know that this has to be 50 degrees. Now, what I have is, I'm just going to redraw this, the bit that we actually kind of care about. So what we have is, we have a quadrilateral here, containing the center point O. On the right, we have 75 degrees. On the bottom, we have 90. On the top left, we have 90. And here then, we have 80 plus A. So again, opposite sides of a quadrilateral opposite angles need to add to 180. So 80 plus A and 75 have to be 180. So 80 plus 75 plus A have to be 180. So A has to be 25 degrees. Okay? So hopefully, wait. Is that definitely right? Sorry, just 1 second. I'm just thinking. Yeah, nope, that's fine. So yeah, that's 25. And then to figure out what B is, I can look at this triangle in here and say, well, I've A, B, and 25. Add them all up, I need to get 180. So A plus B plus 25. A is 25 plus 25, that's 50. So B is 130 degrees, like that. Okay? Okay, yeah, I might do another one because some of these can be very, very hard. Now, to be honest, I think if you can do these, then, you know, you're kind of flying it, to be honest. Yeah, I might do this one. So it says, here's a straight line. You have one big circle here. You have a smaller circle. They're touching like this. You're told the radius of the big one is 12 and the radius of the small one is 3. And it says find what is, so I'll call this A, this B. They want you to find what this length is. Okay. Well, first things first, I can make a right angle. And I can say, well, I know this is 12 plus 3 because this is a radius of the big circle, this is a radius of the little circle, and therefore R plus R is 15. So you get 15 and 12, okay? And then on the bottom, you'll get 9. It's using Pythagoras' theorem. So again, this is one of the things that you can get quite quick at because you can see how quick that I'm doing it. Because that's just a 3, 4, 5 triangle. So see the way I saw 12 and 15, I said, oh, if I divide those by 3, I get 5 and 4. And therefore the other one must be 3 multiplied by 3, so 9. Okay, so A and B is just 9. The next thing you want you to do, they want you to find this length here. That's again grand, because you have 9 on the bottom, you have 3 there. So you just use Pythagoras. So we'll call it D. So it's D squared is going to be 3 squared plus 9 squared, 90. So D is just 3 root 10. And that's it. And again, they ask you to find OB, but that's fairly grand. OB is just this distance here. So again, it's it's 12 up, and then it's 9 across. So that should be fine. I did that wrong. Okay, guys, I'm really sorry. I'm just gonna redo this. Sorry about that. So in case any of you were sitting there being like, what is he doing? I apologize. So sorry, everything was grand. You have one circle here, you have a smaller circle here. This is 12, this is 3. They want you to find this distance. which is grand. Again, this is 15 because it's just 12 plus 3. This isn't 12, it's 9. Sorry, because this height is 3. So if you take 3 off 12, you're left with 9. So this distance here is 9. And so this is actually 12. So it's still a 3, 4, 5 triangle, but it's the 3 is on the left and the 4 is down in the bottom. So sorry about that. So this distance is 12. And if I want to find the next distance, it's d squared is going to be 12 squared plus 3 squared. That's 151. So d is just root 151. Okay. So yeah, sorry about that. And that should be 3 root 17, I think. Wait, should that be a... Sorry, that should be a 3. Yeah, that makes more sense. So it's going to be 3 root 17. And then, yeah, that's it. So that's with that one. Okay. All right. The next ones... So, yeah. So all of these we've kind of done before. I'm going to do one of these because it basically, they want you to do like a proper proof. Okay? And how do you actually do a proper proof? Okay, so that's going to be the next thing that I'll have a quick look at. So it could be something like prove that angle 1 plus angle 2 plus angle 3 equal 360. Like this, where you have a triangle. That's angle 2. That's angle 1. Sorry. This is angle 3. This is Y. This is Z. This is X. So prove all these. So basically, what you do is, so this is what you're trying to prove. Okay? So now, what I'm going to do is, you basically say, well, I know the exterior angle has to be equal to the interior angle. So angle 1 has to be equal to angle X plus angle Y. Angle 2 has to be equal to its interior angles, which is angle Z plus angle Y. And angle 3 has to be equal to angle Z plus angle X. Now, if I add these together, because that's what I want to do, I want to add these. So again, you always have to give a reason. So it's going to be exterior. So you always say what you want, and then your reason for saying so, okay? And that's just all the same thing. So now if I add all these three together, I get angle 1 plus angle 2 plus angle 3 equals 2 into angle X plus angle Y plus angle Z. And then the reason for this one, you just say add 3 lines together. Okay? Then you'd say this is equal to angle 1 plus angle 2 plus angle 3 equals 2 times 180. And you'd say 180 equals 3 sides in a triangle. Okay, so you're just saying that X plus Y plus Z has to be equal to 180 because it's just the 3 angles in a triangle. And then this is 360. And then you'd write at the end QED. So QED is quod erat demonstrandum, and it's Latin for what was to be proved. It's basically just, you just write at the end of a proof just to say you're finished, that the proof is finished. Because why? Because what did I end up with? I ended up with angle 1 plus angle 2 plus angle 3 equals 360, which is exactly what I wanted to show. Okay? So that's how you do a formal proof. So you basically do the maths here, and then your reasoning here. So not too bad all in all. All right, we're almost finished this chapter, which is, I'm surprised how fast this is going. Okay. Very last one is basically like similar triangles. Okay, and these personally I find the hardest. Okay. So it could be something like this. So this is X, Y, Z, A, B, C, D. And you're told in the diagram that X, Y is parallel to BC and YZ is parallel to CD. So these are parallel. Okay? So now what they're saying is prove that X, Z, so this line, is parallel to this line. And you might sit there and say, I have absolutely no idea as to how I could possibly do that. You take it in steps. You'd say, okay, well, if these are parallel, then what does that mean? Well, that would mean that this side divided by this side would be equal to this side divided by this side. Okay? So remember, if you have your triangle like this, and these are parallel, and that's A, B, C, D, then A divided by B is equal to C divided by D. Sorry, that should be a D. Okay? So that's it. So basically, that's what I want to show. I want to show that those, so if, assuming these lines here are parallel, then I should get this. So what I want to prove that AX divided by BX is equal to AZ divided by DZ. Okay. Well, first of all, let's start off with AX divided by BX. What's that equal to? Well, that's equal to this divided by this. So it's equal to AY divided by YC. Because these two lines are parallel. But AY and divided by YC is also equal to AZ divided by DZ. Why? Because this is parallel to this, and therefore they will also have a relation between them. Okay? And therefore, this equals this, which is what you're asked to show. And that's it. Okay? Yeah, I think I might do one more and then I think I'll leave it for today. Yeah, I'll just do one more and then I think I'll leave it there for the geometry side of things. Actually, sorry, no, that's kind of the exact same thing. Let's do something different. Okay, yeah, let's do this one. So this one, you have a line down here. This is at right angles. This is D, A, C, B. So first of all, they want you to show that the triangles A, C, D is similar to triangle C, D, B. So just show that they all have the same angles. So first of all, if we look at this one, label this as angle alpha. If this is alpha, this needs to be 90 minus alpha. Okay? So hopefully that makes sense. So now, next thing to look at is so label this one now as beta. This now would have to be 90 minus beta. Okay? So that's fine. So I've just labeled the two of them. I just said, okay, there's alpha and beta. Yeah, whatever. I'm being very hand wavy for the minute. Now the next thing, I can look at the big triangle and say, well, this angle plus the top two have to be 180. So alpha plus, okay, no, that doesn't help me. Sorry. Sure, is similar. So they both have the angle. That's fine. Okay, I'm actually not sure. Because if I do that, then I just get the same thing. So this is obviously the wrong way to go about it. Okay. So hopefully it's clear what I need to show. I need to show that this is alpha and then beta and beta. That's what I need to show. Given that that's alright. Yeah, sorry, that's my fault. See, this is one of the things that you should kind of learn from me, because of course I'm going to make mistakes as well. In the question, I was told that this is 90 degrees. So sorry, that's my fault. So it does work, because this is 90 minus alpha. This is 90 degrees in total. So whatever angle I put in here, whenever I add it to 90 minus alpha, I have to be left with 90. So it's alpha, because 90 minus alpha plus alpha is 90. And then this is 90 minus alpha. So therefore, I've shown that this angle is the same as this. This angle is the same as this. And clearly, this angle, sorry, I should use a different color. This angle is the same as this. So sorry, that's my fault. That's another thing. If you can't figure something out, it could just simply be due to, oh well, I probably just forgot to put in something. Okay. The next thing they want you to do, they want to show that AC squared. So this length here, so I'm going to call that D, is equal to AB. So this length, call that L just to make my life easier, times AD, which is this length here, H. So you want to show that D squared is equal to H times L. Okay? So I suppose very first thing, I can use Pythagoras. I'm going to call this Y, and I'm going to rewrite it in terms of D and H. So Y, I can say, well, Y is simply going to be D squared is going to be Y squared plus H squared. So Y is going to be the square root of D squared minus H squared. And this length here is going to be L minus H. So in this kind of triangle from C to D to B, I can now find the hypotenuse there, which I'm going to say is M. So I can say M squared has to be equal to Y squared, which is going to be D squared minus H squared, plus L minus H to be squared is L squared, plus H squared minus 2LH. So I get that M is going to be the square root. So the minus H squared and the plus H squared cancel. So I'm simply left with D squared plus L squared minus 2LH. So that's fine. So now what I can do is I can get the so again, this is what I want to show. So I want to do probably the cos of alpha. Okay, it should work out. So if I do the cos of alpha from here, so cos alpha from the left triangle is going to be h over d. And then the cos of alpha yes, the big triangle. So the very big one. So the cos of alpha in the really big one then is going to be d over L. Yes. And then cross multiply, I get d squared is equal to L times h. So all this working out that I did with m actually wasn't necessary. Because you can just use this triangle here. So the cos of alpha from this triangle, and then the cos of alpha of this triangle. And that gives you this thing, which you're asked to prove. Okay? Fantastic. Okay. So I think I will leave that there for today. I'm going to do enlargements in the next video, and then it's going on to coordinate geometry. Okay? But yeah, I think I'll leave that there for today. So thank you very much for listening, and I'll talk to you next one. Bye.